Welcome back, Focus Learners. Today we're diving into a brand new explainer on optimizing card sorting. Let's be real, if you've ever spent hours just staring at a wall of hundreds of sticky notes, desperately trying to find patterns in user data, you know exactly how tedious it gets. Well, today we're looking at a massive shift in how information architecture is built. We're going to explore this idea of an AI copilot. It's an absolute game changer for accelerating your research workflows, but without losing that crucial human nuance that makes UX research so valuable in the first place. Okay, let's jump right in.
So think about this. Can an AI actually map the mind of your user before you even recruit your first participant? It's a pretty provocative thought, right? And the short answer is yes, to an extent. By using large language models to simulate user mental models early on, we can generate some incredibly powerful baseline hypotheses. But as you'll see throughout this explainer, the real magic doesn't actually happen when the AI gets it right. Nope, it happens when human participants prove the AI wrong. Here's our roadmap for today. We're going to cover the two main roles of AI, dive into AI's specific uses in open, closed, ranked, and hybrid card sorting, and finally wrap up by looking at how to validate all of this with similarity matrices. Starting off with Section 1, the two main roles of AI. Now, this is the foundational framework you really need before you throw any tool at your research data. I like to call it the rule of two for AI in UX research. Notice the clear division of labor here. Over on the left, we've got simulation. This is basically the predictive superpower of tools like ChatGPT or Claude. You just feed your content items into the LLM and ask it to sort them from your target user's perspective, literally in seconds. Then on the right side, we have analysis. This is the processing superpower of dedicated platforms like Maze or Optimal Sort. Once you have actual human data in hand, the AI steps in to rapidly merge similar labels, visualize clustering, and summarize patterns. So, simply put, simulation predicts, analysis processes it.
All right, let's move into Section 2, AI and open card sorting.
Now, open sorting is kind of the Wild West of information architecture, right? You're building structure from scratch and learning exactly how users conceptualize your content. And because it is so open-ended, your AI copilot is going to flex its muscles the hardest right here. Check out this master overview matrix. It shows exactly how AI's involvement shifts depending on your methodology. Look at that top row for open sorting. AI use is high for both simulation and analysis, but if you scan down to closed or ranked sorting, simulation drops to low. Why? Because you've already defined the parameters. Understanding this matrix is absolutely key to knowing when to lean heavily on your AI copilot and when you need to grab the wheel yourself. So, how do we leverage that high AI involvement in open sorting? Well, before you even recruit your typical 15 to 20 human participants, try running your list of cards through an LLM 3 or 4 times. Consistent groupings across those runs will reveal strong natural associations. And on the flip side, the inconsistencies will flag ambiguous items that you definitely need to keep a close eye on during human testing. Then, once that human data starts rolling in, the AI can literally compress days of analysis into minutes. It'll automatically merge dozens of slightly different participant labels, generate clustering diagrams instantly, and it'll even summarize the qualitative think-aloud feedback from your testing tools. Talk about a massive time saver.
But we absolutely have to talk about the golden rule here. AI is incredibly fast, for sure, but it simply cannot capture context-dependent mental models. The AI baseline is literally just that, a baseline. Those specific moments where your human participants completely diverge from the AI's prediction, that is exactly where the true contextual insights live. That divergence is the why behind user behavior. And let's be honest, that why is exactly what you are being paid to find.
Moving right along to Section 3, closed and ranked card sorting.
So we're shifting gears now into environments where the parameters are much tighter. In closed sorting, your focus is entirely on validation. You already have predefined categories, so AI simulation really takes a back seat here. Instead, you'll want to use AI beforehand to review your labels and flag what we call keyword matching risks. These are words that might accidentally lead participants to group cards together just because they sound similar, creating a false sense of agreement. Now, for ranked sorting, it's all about prioritization, and this relies absolutely on human judgment. AI cannot tell you when a user values most. It can only process the resulting data to highlight priority patterns across the whole group.
Which brings us to Section 4, hybrid sorting and clustering.
Hybrid sorting is super interesting because it lets users utilize predefined categories, but it also gives them the total freedom to invent completely new ones. But because of that freedom, hybrid data can get messy, and I mean really fast. To tame this chaos without losing the nuance of those new user-generated groupings, we follow a very strict 3-step workflow. First up, Export your structured data, making sure to explicitly flag which categories were predefined and which were user-generated. Second, you need to standardize those wildly varying user-generated names. And third, cross-reference those new clusters back against your predefined structure. Let's look at exactly how to prompt your AI to do this heavy lifting.
All right, this is your Phase A prompt. You're going to feed the LLM all your unique user-generated category names along with the cards inside them and give it this exact task. You're basically asking the AI to clean up shared keywords and standardize those chaotic names. For example, the AI can easily recognize that one user's team events and another user's work culture are functionally the exact same bucket. It gives them a unified, clean label while preserving all the original card data so you don't lose anything. Now, you might be wondering, why do I need to run this standardization prompt multiple times? It's a totally fair question. Because LLMs are probabilistic by nature, running the prompt 2 or 3 times with slight variations helps the AI catch its own inconsistencies. If the AI repeatedly suggests the exact same unified cluster name across multiple runs, then boom, you can be highly confident that this new standardized label is truly reliable and representative of your data.
Once everything is standardized, we move into Phase B with this specific prompt. Here, you feed the newly cleaned user clusters and your original predefined categories back into the AI. You are forcing the AI to critically evaluate, is this user's new category genuinely necessary, or should we just merge it into a predefined one? You see, in hybrid sorting, users often just recreate categories that sound awfully similar to your existing ones. By asking for a confidence score and reasoning in this prompt, you can easily detect a redundant category versus a truly necessary new addition to your architecture.
Okay, let's dive into Section 5, Validating with Similarity Matrices. We've done a lot of AI manipulation so far, right? But now we absolutely must ground it all in hard math. Consider this simplified similarity matrix. This right here is your undeniable ground truth. LLMs just cannot naturally read raw, underlying spreadsheet data the way a statistical tool can. This matrix quantifies the exact percentage of participants who grouped any 2 given cards together. For instance, look at this. 85% of people grouped team retreat with office party, but only 12% grouped team retreat with employee benefits. You can't argue with that. This is hard mathematical proof of user mental models. So what do you do with it? You feed that similarity matrix data straight into your LLM using this interrogation prompt. You are specifically asking the AI to find the mathematical outliers. We want it to highlight the cards with weak correlations, the cards that participants clearly struggled to place accurately. If a card has a low agreement percentage across the board, it usually means the label is confusing, or maybe the item naturally belongs into 2 different places and might need to be cross-listed in your navigation. Now, if you're using an advanced tool like Optimal Workshop, you might be looking at a dendrogram. That's one of those branching tree-like diagrams that show data clusters. If your data is messy with a ton of poorly correlated cards, an LLM cannot just look at that image reliably. You actually have to translate it for the AI. You'll want to describe the sparse branches and strong clusters in text, and then ask the LLM to sanity check that visual data. Ask it something like, based on these 12 low correlation cards, should I accept the main 3 clusters, or is the data demanding a 4th category? After running through your hypotheses, standardizing all those hybrid names, and checking the similarity matrix, you hit the AI with this ultimate master prompt. You are basically asking it to synthesize all of the preceding qualitative and quantitative analyses into one comprehensive, ready-to-test information architecture structure. This pulls together your predefined categories, your validated user-generated categories, and mathematically sound cross-listings into a single cohesive output. It's a game changer. Before we wrap this up, let's quickly summarize some core best practices to keep your AI copilot and honestly your whole research project on track. First, keep your card count between 30 and 50 to manage human cognitive load. Nobody wants to sort 100 cards. Always use AI beforehand to review your labels for any shared keyword bias. In hybrid sorts, rigorously flag predefined versus user-generated categories so your AI doesn't get confused. And this is absolutely crucial. Always include a few moderated, human-led sessions so you can actually talk to participants and ask about their choices. Finally, make sure to tree test that beautiful final structure to validate that real users can actually find the content. And that leaves us with this final, really vital question. AI can process the data in seconds, but can it understand the why behind your users' choices? Ultimately, the answer is no. AI handles the what at an incredible scale, pulling back the curtain on the structure of the data. But as a researcher, it is still on you to uncover the why. You have to find the human context, the hesitations, those subtle mental models that literally only a conversation can reveal. So use the AI for speed, for sure, but rely on human connection for true understanding. Thanks so much for joining me for this explainer, and I'll catch you in the next one.